All right, hello my Algebra 2 students. Mr. Alent here, just going over some logarithms. Very, very basic way to look at logarithms and just kind of the introduction to what a logarithmic function is. And so logarithm, this is really new to you guys. I don't think you didn't see this in Algebra 1. This is a whole new introduction here to what logarithms are. And the key is really right here, this little phrase right here. Logarithmic equations are the inverse equations to exponential equations. So if you think back to last week, we learned about inverse equations. We learned how to find the inverse of, mostly we were looking at linear equations last week. So finding the inverse, remember we would like replace x and y and then solve for y, and that would find us our inverse function. But how do we do that if it's an exponential function? An exponential, remember an exponential function is some number raised to the power x, right? How do you find the inverse of that? Like if I were to do what we did, if I changed this as a y and then replaced x and y, how do you solve for y? We've never, in our time in algebra, let me kind of show you what I'm talking about here. So that would be our first step, replace f of x with y. And then we would replace x and y. And now we would say solve for y. Well, how the heck do you solve for a variable, or for an exponent? We've never done that. We've never solved for an exponent. X equals b to the y. How do I get y alone right now? How do I get y out of the exponent's place? And we've never learned how to do that yet. That's where logarithms comes in. That's what logarithmic equations do for us. So let's see kind of what these look like. Here's a very similar equation to what you saw right here. Y equals b to the x is just instead of y, it says a. So b to the x equals a. This is our exponential equation. How we find the inverse of this, again, logarithmic equations are inverses to exponentials, is we would say the log base b of a is equal to x. Where again, x is that exponent. We just set up here, how do I find y? How do I find that exponent? This is how. The exponent is equal to the log base b of a. Okay, now I know that didn't make a lot of sense right now, but let's go through a few of these and I think you'll start to see what's happening. A couple of notes here. B must be bigger than 0. The base here of the exponent must be bigger than 0, and it also can't be 1. 1 to any power is just 1, so it's not really even worth discussing. So, okay, so here we're just going to practice the conversion. How do I go from this form to that form? That's what we're doing. Write each exponential equation in logarithmic form. So 2 to the 6 equals 64. That's true, right? 2 to the 6th power, 2 multiplied by 2 6 times, is equal to 64. How would I put that into this expression? How would I go the other way? And so again, notice where things are. The b that you see here, that's the base of your exponential equation, is the base of your logarithm. Okay? And then what happens is the a is actually right here, and then that exponent is on the other side of the equals. And so let's try to apply that here. 2 to the 6 equals 64. Well, 2, that's our base, so this is going to be the log base 2, and that's how you write it. You do like log subscript 2. And then it's of, and it's going to be this other number that was out here, 64. And that's going to equal that exponent, which was 6. Okay. When we show you how to actually solve these, right now this is just a conversion. This is from there to there. Those are basically equivalent, or they're inverse functions. But we'll show you how to solve them, and maybe it'll make a little bit more sense there too. Okay, so we have 7 to the 0 equals 1. We want to convert it. All right, so we're going to do log base 7 of 1 equals 0. All right. Well, again, one way to think about this, 7 to what power equals 1? That power is 0. 2 to what power is 64? That power is 6. All right, so again, this is the exponent out here. This is the power, right, if you want to talk about it like that. Okay, so then when we have, all right, we got an x in here. 3 to the x equals 81. And so how do we convert that? Again, that would be log base 3 of 81 equals x. Log base 3 of 81 equals x. That's our conversion there. Okay. We're not solving right now. It just says write them in exponential, the exponential in logarithmic. So I'm not going to solve, just showing you the transition between the two, the conversion. Okay, 4 to the third is 64. So we would say log base 4 of 64 is equal to 3. Again, we're saying 4 to what power is 64? That would be to the power of 3. Okay. If we see number 5 here, x squared equals 25, so we would have log base x of 25 equals 2. Okay, so x to what power, x to what power is 25 equals 2 is how that one would look. Again, we're not necessarily solving for x right now, just showing you the conversion. So then this last one, log base 7 of x equals 2. So again, you can see where things are going. It's been the same all 6 examples. Okay, that's the conversion for doing these. Well, let's go the other way. If we give you the logarithmic form, can you put it back, right? Write each logarithmic in exponential. So go the other way. So when you see log base 7 of 49 equals 2, the 7 is our base. So this is 7 to the power 2. That's going to equal 49. And that's true, right? 7 squared is 49. Great. Over here, 2 to the negative 2, right? So the base is 2. The power is negative 2. And that's going to equal 0.25. Which is true. If you remember, again, negative exponents, that means reciprocal. So this is like 1 over 2 squared. Well, 2 squared is 4. So 1 over 4 is a quarter. That works. All right. So we got log base 9, which means our base is 9. And the power is 0. 9 to the 0 is 1. All right, our base is 8, our power is a negative 1, and that equals 0.125, right? 8 to the negative 1, again, that's reciprocal, so 1/8 is 0.125. All right, we got log base 5 of 5 equals 1, so our base is 5, our power is 1, 5 to the first is 5, sure enough. And we have base 12 to the second power is equal to 144. And there you go. Okay, so there's our conversion. That's been able to jump between exponential to logarithmic or logarithmic to exponential. If you need to watch this several times to kind of get that pattern, go for it. Again, hopefully it'll make more sense as you see examples. Some just special properties for logarithms. If the two numbers here are the same, if log base b of b, if those b's are the same number, that's going to always equal 1, just like it was right here. Right? 5 and 5, same number, that's going to equal 1. That's because of this, because 5 to the first is 5, right? So whatever that number is, if they're identical, you're going to have that it's going to equal 1. In the exponential form, there it is. It's like we just talked about. Here's an example. Log base 10 of 10 is equal to 1 because 10 to the first is 10. If you take the logarithm of 1, no matter what the base is, if the base could be anything, it doesn't matter. If you do log base b of 1, that's going to always equal 0. Because, again, go back to the exponential form, b to the 0. Any number raised to the 0 power is 1. So another example, log base 10 of 1 equals 0. That's because 10 to the 0 is 1. Okay. All right. On the back side, and again, these notes are provided. Hopefully you printed them up and you're doing them with me. Looking at them with me anyway. We'll see if we can get through this. I don't know if we're going to be able to get this all into one video. So maybe let's actually end this video there, and I'll make a second video right now for the second half of these notes.